We're back with another episode of the Dr. Joe Show, joined by himself, the man, Dr. Joe. Thank you, man.
Thank you.
Any more feedback since the last few, now that we've done like 2 professionally shot ones and 2 semi-professionally ones by me?
Well, yeah. So the main piece of feedback was to switch the table around. So we're trying this out and see how it goes.
We're also playing with different locations. Like we have plans to do it in restaurants, different places we think are cool. And you have someone that's like a friend that has a health shop. So that would be actually cool to do it.
I would like to go over there. I haven't asked them yet, but
let's do it. So Western diet, Western lifestyle, which a lot of it is diet. Diet, lifestyle plays a role in epigenetics. We're only now beginning to understand.
Yeah,
I think, right? How long have they known the
epigenetics?
Yeah.
That's, I don't know exactly how long they've been talking about it. I think epigenetic has been thrown around as a term. I think they're always studying it.
It used to be a theory.
It's definitely not a theory anymore.
Right. When did that shift happen though?
Well, I think...
I think it's when the stuff was undeniable.
I think they're trying to prevent the shift because if you talk about epigenetics too much, then people might start to realize that they actually have more control of their health than they're led to believe. Because you just follow the basic protocol of take care of yourself and you won't need half the medications that people end up going on.
I was reading I can't remember. You sent me so many papers, and it could have been one that you didn't send me.
Yeah.
Certain elements of obesity could be passed down to your children.
Yeah. So there's some, I'm going to say misinformation that the most common cause of obesity is genetics. It was some ridiculous claim that was made recently, and there couldn't be anything farther from the truth. And I think that's a good thing to talk about today while we're talking about the Western lifestyle
and the mindset too, right? Because we live in a time of such abundance for, I mean, food is the easy one, but cheap things like cheap soaps, cheap shampoos, cheap pesticides, sunblocks, all these things we've kind of discussed on previous episodes. Cheap drinks, cheap beverages. Not sponsored by Zevi. Zevi is actually one of the good ones, and it's not cheap.
Yeah, this one's not cheap. I mean, it's better to buy them in bulk. The singles they're crazy.
So I guess where do we start? Because we've kind of touched on aspartame, sucralose, the whole diet soda light movement. We've done estrogen narration,
which I think we're going to reference heavily in a lot of podcasts.
Those things keep coming up. No matter what the topic is, we seem to keep coming back to that book.
Yeah. I mean, we're all breathing parabens most of the time. There's 80 million gallons of atrazine on our soil every year, all over our food, which goes into the air. There's red food coloring. There's plastic everywhere. There's phthalates in your steak.
And the steak.
It's just putting it together in a way that's palatable to the audience that they have something to do with it.
So maybe we should follow, because I work in clinical research for those that don't know. Joe will hopefully soon be a sub-investigator for us.
I hope so.
On a study. It's an obesity study. And what I was going to say is if we follow the money's being invested right now in R&D.
Yeah.
Besides vaccines, because that was where it used to be going. Yeah. It's still going there, but it's going towards obesity. If we follow where the money is being invested, I think that's a good way to see, like Wayne Gretzky said, you don't go to where the puck is, you go to where it's going. And so if we look at what the industry is trying to push out next, it was vaccines. It's still maybe going to be. And then you got to take cancer out of it. That's like its separate beast.
Yeah.
It's obesity right now, autism, Alzheimer's, GI stuff. A lot of GI stuff. NASH, kidney, and derm. Atopic derm especially. Which means what? It's like dermatitis that they have no known cause for, basically.
Yeah.
Autoimmune. How many of these things are autoimmune? Like, let's say obesity. Is that
There are autoimmune causes of insulin resistance. That is a thing, but that's probably not the most common cause of insulin resistance.
Right. So maybe the best place to start is a series of risk factors called metabolic syndrome.
Yeah. Syndrome X.
I was diagnosed with that at one point, unofficially diagnosed. It's never been on my records, but the doctor was like, most likely your issue is insulin resistance. And there's this group of cofactors that you have called metabolic syndrome. Mm-hmm. It scared the hell out of me. I was like late 20s and I didn't know what the hell that was. So I had to Google this stuff and I saw SHGB, sex hormone binding globulin. I saw its relationship to testosterone and luteinizing hormone and all that stuff. So maybe we start there with like, why are young people getting these things?
Well, it's a number of things, I'd say. Syndrome X, it's the high blood pressure, the obesity, the excess fat on the body, and insulin resistance. And all the things that come out of that. You get too much insulin in your body, you cause excessive sympathetic activity, and you make your kidneys reabsorb more sodium out of your urine so that your pressure goes through the roof. And you look at your food, you look at what you're putting in your body, you got all this extra salt and all these extra, we could say, empty calories that just go straight to your liver and get turned into fat.
Yeah. And so, okay, insulin resistance. So let's just break it down real basic. Mm-hmm. When a normal person eats something with sugar, right? Mm-hmm. It goes to the stomach. Mm-hmm. GLUT4 transporter. Where does that come in?
You got a lot of GLUT transporters. I mean, there's GLUT 1, 2, 3, 4, and there might be more now that I don't know about. But fructose actually goes in through GLUT4, and it goes in completely unregulated. It just slides right into your.
So that's from like natural fruits, right?
Yeah, it does. It comes from natural fruits, but not all of the sweetness in fruits is fructose. There's fructose, there's sucrose, which is a disaccharide. Okay. It's a glucose stuck to a fructose and it's just stuck together. You can't polymerize it. It's just a disaccharide, two sugaride. Okay. That's like your table sugar. Okay. That's like the white granulated sugar. But in a lot of fruits, there's the polymerized, starch-like stuff. There's vitamins in whole fruits. There's minerals. There's fiber. There's pectin. There's quercetin, for example. Quercetin is in apples.
That came up a lot in COVID.
Quercetin. There were a lot of studies showing quercetin as having a factor in activity against COVID. But whole foods, you eat a whole food to get all the benefits from it. And so when you go and buy juice from a fruit, you're not really getting the whole fruit. You're just getting mostly the sugar from it. And that's where we run into problems, because I think that just from experience, see, we're again back to the clinical experience and the personal experience and basic biochemical physiology. That's where everybody should start. Okay. If you open up a mineral supplement and you just dump it in your mouth and you taste it and you swallow it with just a gulp of water, it's not going to taste very good. Okay. And it will kill your appetite like instantly. Your appetite is, whoa, okay, I'm not hungry. When you drink a soda with high fructose corn syrup and there's no minerals in there, you want more and more and more and more. But not the case with Zevia, folks. Zevia has stevia and that suppresses your appetite. But anyway, so you have all these foods that have no nutrients in them and they sort of propagate more and more hunger, and you can't get full because it's sending a chemical signal like, oh, there's minor amount of nutrients in here and there's all this dopamine hit fructose in here. So maybe there's more because maybe we should just keep drinking. And so your brain goes into this little loop and you just keep wanting to eat and drink the bad stuff.
And there's probably back to the caveman days, right? you found an orange, that would be like your reward for the day.
Yeah.
That's probably what triggers it was that sweetness that makes you want to eat it because of the other good stuff.
Yeah.
In it.
We're built to fast. Humans are built to fast. And when we don't fast, we get sick. That's it.
Fasting's changed. I wouldn't say my life. It sounds dramatic, but definitely keto and fasting did change my life, I think, for the better. Dropped 50 pounds. No more metabolic syndrome. I was, we'll get into that later, but okay. So just like for the lay people out there, as your body gets more accustomed to having glucose just in the blood, your insulin becomes resistant. What does that actually mean? Like physically, like does the insulin no longer care to open the cells up to allow the glucose, or doesn't work, or what?
Well, the issue is the primary job of your liver is to make glucose. And when you're sending signals to your liver that we don't need you anymore, we don't need you to make any more glucose, then your liver kind of gets upset with you and doesn't work very well. And that's a very oversimplified way of putting it, but you're putting exogenous glucose in the body, extra glucose from the outside. And then now there's a context. What is your body doing when the glucose goes into it? Okay. When people are doing workouts and they're recovering from a workout, let's say you go and you do a bunch of deadlifting, a bunch of benching, and your workout is nice and short and intense like it's supposed to be.
Right.
And you're pretty sure you got ripped, right? You caused micro tears so that your muscles will grow. Well, now you're going to go have something like a protein shake or a bunch of boiled eggs or something. But it's okay to have glucose at that time because your body is going to use it in the restorative repairing mechanisms for the micro tears that you just made. And you're going to make your muscles get bigger. Now contrast that to sitting around.
Western lifestyle,
sitting around, and we're going to just eat a bunch of potato chips. And we're going to just sit on the couch and stare at the TV. So now you're not using your muscles. You have all this polymerized glucose that's being broken down in your stomach, and it's going... well, in your stomach and in your small intestines, your pancreas puts all those enzymes out there and start breaking it down. Now that glucose is going to go into your bloodstream, and then you're going to get insulin release. Okay.
From the pancreas,
from the islet cells.
The islet cell. Yeah.
And so then that insulin then signals for the glucose to be transported into the cells. Glucose needs to be phosphorylated. And then that glucose will get turned into fat for the most part.
No matter what cell it goes to.
Depending on what cell it goes to. But like it's going to go to your adipocytes, your fat cells. And you got fat cells all over your body.
Everywhere. Yeah.
So that's the short of it.
But when they say insulin resistance, so the insulin is no longer able to work well as a key to open the receptor for the glucose, or it just refuses?
Well, yeah, there's so much fat storage going on, I think, that you need more insulin to actually send the signal. Think about the cells. The cells are being stretched.
Okay.
Adipocytes get pretty big. Think of it like this. You think of a cell of a plant. Like a plant cell. Usually you're thinking, oh, I'm going to look at it under a microscope, but you take apart an orange and those cells are engorged with liquid, right?
Right.
Just the same that those cells can expand and contract, our adipocytes expand and contract. And so I think that when you take a cell that's supposed to be a certain size and now you've stretched it to a bigger size, it has the same number of receptors on it. So now, in order for the cells
surface area,
for the cells to see the insulin, then you need to have more insulin around. And
which the body does do.
Yeah, it does eventually, but now you have more insulin.
I see.
And the more insulin you have, then the more weight you gain because when you're taking extra insulin or when there's extra insulin, it causes more fat storage to happen.
Do the insulin receptors ever get covered by fat? Is that
the receptor get covered by fat?
Is that why the insulin can't bind?
No, I just think that you have to get around to find it on the molecular level, because now like your cells are yay big and now your cells are yay big.
Okay, I see.
You see what I mean?
So it's just like statistically going to be harder for the insulin to connect.
It's the same reason why A1C is a measure of your average glucose. And because A1C is a measure of the percentage of hemoglobins that have a glucose stuck to it. And so when you have more glucose interactions, that's a sign that there's higher glucose concentrations, higher chance of impact, higher chance of making an A1C out of a regular hemoglobin.
So initially when your glucose goes up and spikes, your pancreas releases insulin. But over time, the insulin becomes resistant.
Yeah.
Basically because it's larger surface area and it's the same number.
I think that's one reason why. But I mean, I think there's... And
they still don't know these things, right?
It's not totally completely understood, but I think that's at least one mechanism that I would think of just from a very simplistic structural side.
And so the long-term effects of this, diabetes, neuropathy, why? Why the neuropathy?
Why the neuropathy? Oh, the nerves lose blood flow. And think about this. Your A1C is really high all the time, right? And you have hemoglobin in your red cells. So let's say your A1C is supposed to be, well, let's say it used to be 5.1%, whatever. Well, now you have a person who used to have an A1C of 5 and now their A1C is 10%. That's really high, folks. Really, really high. That's a dangerous high. A1C if you're doing nothing about it, if you have that anyway. So now you have twice the number of A1Cs inside that red blood cell, right? Now, red blood cell is shaped like a rolled up, well, kind of like a donut with a little septum in it, or, kind of like a rolled up condom, you could say. Okay. Well, now you increase the A1C and you have more glucose in there at any given time. So what's it going to do? It's going to pull more water into it. And so now those red cells are now like partially inflated whoopee cushions. So you try and cram that cell into a capillary and the capillaries die one by one. And then that kind of leads to vascular disease. But that's one mechanism I can think of, is that the blood vessels, feeding the nerves slowly die and rot away. But again, we're talking about neuropathy. And we're also talking about something heavily associated with diabetics, which is aspartame. Okay. We're coming back and folks,
episodes about this.
And folks, this is not a Diet Zero Light episode. Episode 3 will be later, but we're going to have to refer back to Diet Zero Light here. Aspartame is neurotoxic. It kills neurons. Aspartame kills neurons. Okay. Just everybody, don't forget that. So it kills your neurons. And so you get neuropathy. And for some people, it's more than others. But so I think that because there is a lot of aspartame use in probably a majority of diabetics.
Or sucralose, right? Even though that doesn't kill.
Sucralose is not neurotoxic from what I've read about it. And I don't know if there's been studies done on that. I know sucralose influences insulin slightly, but
I see.
Not so much with the neuropathy as far as I know. But aspartame is by far the worst.
And aspartame, the diabetics drink it because they say, hey, well, it's sugar-free.
Well, yeah.
And somebody probably told them.
Like the American Diabetes Association, funds, well, they get their funds from food industries. Okay. And then that education is tainted.
Right.
I'm sorry, guys. Prove it to me. Prove it to me if I'm wrong. Okay. It's unfortunate, but it's true. This idea of scientism and follow the money.
Well, we got to do a whole episode on scientism.
Yeah. But I guess it leads into our conversation because we're talking about the metabolic syndrome and Syndrome X.
Right.
And we were going to talk a little bit about cortisol. I know we wanted to tie in the cortisol.
I think we have to, but
yeah.
It seems like I was saying earlier, follow the money. It's a more than usual amount of money going into cortisol research now for a variety of different conditions.
And I think the omega-6 and the omega-3 discussion, I think the food industry thinks they've won because they've beaten the dead horse so hard with their proverbial stick. For the last 10 years, it's just been study after study after study. Omega-6 is great. Omega-6 is great. Well, you know what the food industry forgot about? They forgot about epigenetics. Okay. So
that's where we started this episode.
Well, that was sort of the original concept.
You think they forgot about it, or they didn't realize it was a real thing?
I think they forgot about it, or they deprioritized it. I mean, they're doing all these heavily flawed nutritional studies, which it's very easy to make those studies look however you want.
How to lie with statistics.
How to lie with statistics.
It's only
perfect example.
144 pages written in the 1950s.
Yeah.
Highly recommend.
Yeah.
1/3 of the way through.
Watch out before, one of the major platforms that sells books bans it. So
get it while you can.
I'm not going to name names, but anyway, so omega-6, there's a proposed ratio for omega-3, 6, and 9. And like you go to Mayo Clinic's website and they say omega-6 is good for you, but they don't actually say anything specific about how much you're supposed to have. And we have basically forgotten the studies showing that it upregulates enzymes that cause you to create more cortisol via tumor necrosis factor alpha, interferon, and interleukins 1 and 6.
Yeah.
And you get all this inflammation out of it. So these studies that say omega-6 is fine.
TNF alpha, can you explain like just a little bit of what that is?
It's one of the inflammatory cytokines that our body uses to fight off something that's not good. Viruses, infections, tumors. That's why it's called tumor necrosis
factor. I was going to say that's in oncology pathways and mechanisms of action.
Interferon is used for antiviral therapies that we give it to people with certain viral infections, but our body makes a lot of this stuff. But to have the stuff in your body inappropriately, for it to create all this inflammation, that's when you get inflammatory responses in all your cells. You get cortisol release, and you get more storage of fat. You get vascular damage. And when you get this damage over time, you're going to get more plaque buildup. The most common cause of death is heart disease.
And how is that due to lifestyle? The plaque comes from what you eat and from lack of exercise. And what you're not eating as well. The LDL. People say the LDL, VDL, HDL. You got to watch these things.
So LDL doesn't really correlate to anything. If there's anything that's probably a better correlate, it's VLDL. But we need more data on that. Actually, our clinic, it has data about it. We were talking about it recently. We haven't actually looked at the data, but we're going to be looking at it. We have several hundred patients with VLDLs, but the other really important.
Who's crunching data over there?
It's it was Boss, and it was one of the guys from the lab who's looking at the data.
They have like biostatisticians.
Yeah. Well, it was at the meeting last week, but wow. That's why I wish you were there. Like that was probably the most exciting meeting.
Wow.
Because we were talking about the new cholesterol panel that we have. It's an inflammatory panel, and you look at myeloperoxidase, LPA, and CRP, and those are way better predictors of active vascular damage and inflammation, and guiding lifestyle discussions with patients than just clicking a lipid panel and ordering it and say, oh, okay, your LDL is this. Your LDL
so why
is
has
this.
That been the gold standard since I can remember? The LDL. Everybody knows it as the good cholesterol, and
you mean HDL?
Yeah.
HDL. HDL is still the good stuff.
HDL the good one, but LDL
it's still the
one.
good stuff. But the HDL is still the good stuff. It's just its relationship to the other ones matters. So you have a good HDL and you have an elevated LDL. They used to say, well, your HDL is so good, it sort of overshadows your LDL being bad. I think it's a little more complicated than that now, because your triglycerides matter too. Your VLDL, which is influenced heavily by oxidized fats and oils in your diet. That's an indicator. I think it's going to be a bigger indicator than LDL ever was.
And can you break down the different functions of VLDL versus LDL?
Very low density lipoproteins. So they're basically these. It's a type of cholesterol particle, and it's just this fluff that is really bad for your blood vessels. And when there's too much of it around, then it just gets deposited inside your blood vessels, and it contributes to plaque formation. And because not all the LDL is bad, right? You drop somebody's LDL too much with certain medications, and you'll accelerate or cause dementia. You see low LDLs, you see more dementia.
We had a study we never got, but the primary endpoint, the thing they were bragging about, was this dropped LDL in patients 20%.
Yeah. And if only LDL was a worthwhile target,
the culprit,
which it's not.
Yeah. It
appears
not. Like it was just the target for the molecule they were producing or developing at the time.
Yeah.
Okay, so VLDL more important than LDL, but all of these things taken together, triglycerides as well.
Yeah.
It's still possible to get those without getting insulin resistance, right? Like they're not necessarily related, but the Western lifestyle contributes to both.
Yeah.
Well, so is that epigenetics, like determining which one gets expressed in one person versus another? You can have two people on the same diet, one never getting diabetes, but getting hypercholesterolemia, and the other.
I think that's true. There's what I always go back to. I look at probably the most underserved people in our country, which are the Native Americans. Their metabolism is the closest in time to what should be their epigenetic diet, and they spent the most time most recently doing lots of fasting genetically, because what you do in life, to quote Gladiator, echoes in eternity, right? So what you do puts epigenetic markers on your gametes, on your sperm. Okay. Since we're men and men produce sperm, right? And women have eggs. Isn't that interesting? I just gave one of the definite anyway. So what you do, it influences how your kids develop. Okay.
It influences
via methylation, ethylation of certain genes.
And that's essentially epigenetics.
Yeah. That's one of the biggest, probably the biggest indicators that epigenetics is important. So that what you do in life, investing in your health, it's not just good for you. It's good for the kids that you haven't had yet, folks, if you haven't had kids yet. The earlier in life that you invest in your health, whether you're a teenager, whether you're 30, you're 50, it doesn't matter when you invest in your health, but the earlier that you can invest in your health, the better off you're going to be. But again, it's never too late to invest in your health. So if you have
it can affect the offspring.
Yeah.
Which is kind of what I brought up in the beginning of this video, where I said obesity could be passed on. But it's maybe not obesity necessarily. Maybe the more accurate thing would have been insulin resistance predisposition or hypercholesterolemia predisposition, or that's why they always ask you for family history, right? It's important.
Family history is very important because there's it's not just because of genetics. I've realized it's also because what's in your pantry can be just as important as what's in your genetics. Okay. What you learn to put in your pantry. Right. So that's, but yeah, like if there's a family history of early cancers, then you want to get screened earlier, right? If there's a family history of certain degenerative disorders or certain heart problems like hypertrophic cardiomyopathy, I mean, you need to know this stuff. If so-and-so is 19 years old and family members with hypertrophic cardiomyopathy, HOCM, that person needs an echo, for example, so yeah, the family history matters for all kinds of reasons.
And it used to be thought that obesity contributes to diabetes. Mm-hmm. But the research has shown recently that it's actually the insulin resistance that could lead to it.
That leads to diabetes.
Leads to diabetes and then possibly obesity. Because not every diabetic's obese.
No.
For type 2.
Well, it's that the more insulin you have, the more you're storing glucose as fat. The more fat you're storing, the harder it is to turn glucose into fat. So then the more insulin you need, and the more fat you're storing, and the more uncontrolled your glucose is. And then the more vascular disease you will get eventually. And away we go.
Cytochrome P450. You brought it up.
Yeah.
Pre-interview. It's in this book.
Yeah. So Greenspan's basic and clinical endocrinology, it's usually required reading for most medical schools, or something like it, right? We got a really good diagram here. So just in the very, very quick amount of research that I was doing when we were talking about just the cortisol. I don't know if folks can see that, but you got cortisol feeding in here. Then you got pregnenolone here, and then you got 17-hydroxypregnenolone, and then you got DHEA. So these pathways are the major pathways that feed into several of the major hormones in your body, which are because of your adrenal cortex dysfunction. Okay, so this is like your mineralocorticoid side. This is your corticosteroid side, and then this is mostly your sex hormone side. So you got all these things feeding into it, but again, this is what the food industry failed to I'll say doctor, in all the research that they've been making about omega-6. Omega-6 upregulates this enzyme right here, and I don't even know the acronym, but this step from here to here, it gets upregulated, and it pushes more of your cholesterol down into your cortisol side, and so that is that's directly linked to omega-6. Okay. And omega-3s work against that. And so your omega-3s are the ones that are good. So contrast linoleic acid, which is an omega-6, and then alpha linoleic acid, which is an omega-3.
ALA.
Yeah. And don't mix up that ALA with the other ALA, alpha lipoic acid.
Alpha lipoic acid.
Which is a completely different molecule that helps you to regenerate your nerves. So that's why I tell everybody with neuropathy, just start taking alpha lipoic acid on an empty stomach, because it doesn't have any side effects. It's not going to hurt you. And it's a mitochondrial factor that your body is supposed to make. And because we're malnourished, we often have to supplement with mitochondrial molecules.
And these endocrine pathways, precursors, and ultimately leading to cortisol. Mm-hmm. There's also glucocorticoids that people take as medications for asthmatics, right? Glucocorticoids.
Mm-hmm. Use them for all kinds of things.
Which increase cortisol as well.
Yeah, they have a cortisol-like effect. So when you take glucocorticoids for something, you have a patient with a COPD exacerbation, you give them a burst of prednisone. You have somebody with an asthma exacerbation, you would give them, a short course at probably a lower dose of steroid, whatever. You will be suppressing output of your corticosteroids from your adrenals. And so then that's why if you're on steroids for a certain period of time, usually more than a week or two, then you have to taper. Mm-hmm. And some specialists recommend taper even after a week.
Wow.
So that 1 to 2 week, it's kind of like that. Well, I'm not sure, maybe. And it's generally just considered a good idea. If you're on steroids for a week, it's good to just do at least a short taper, something.
And does that apply to steroids people take, like bodybuilders? Or is that a different?
Well, the bodybuilders take, they take the exogenous androgens. Yeah. So they'll take, and usually if they're doing it,
well, those increase.
I don't want to say illicitly. I guess illicitly, some people get them from these third parties, and I guess it is illicit, right? Especially if they're competing, that's definitely illicit. But those are on the sex hormone side, So those are modified versions of testosterone and dihydrotestosterone.
Because I saw DHEA in here as well.
Yes, and that's the precursor to that's one of the precursors of testosterone.
I see. Okay.
And then testosterone can get turned into estrogen, right?
They're all connected. So I guess we were trying to find like the link between insulin resistance and
cortisol.
Increased cortisol.
Yeah.
And there is. It's not so direct.
It's not so direct.
And they don't understand this stuff.
Well, the bottom line is learn how to be hungry. That's it.
Well, we'll get to fasting, but the reason why we're going down this path is we wanted to find out, okay, there's declining testosterone levels amongst this generation of males, probably lowest ever in history. There's also increased insulin resistance at the same age cohort of males at the same point in time. If there's any relationship between the two, or if both are being negatively impacted by environmental toxins like atrazine
and the Western lifestyle. And behaviors too, just behaviors that lead to low T.
Right. And there's no incentives to study this stuff.
There's no incentives.
There's incentives to find cures for all of it.
There's incentives to make drugs, but there's going to be no incentive in any industry to convince you folks to take care of yourselves without the need for all these industries. So, and that's why discipline, getting up early, eating breakfast, exercising, having a decent lunch,
fasting.
I always tell my patients the most forgivable time to have carbohydrates is going to be earlier in the day. If you're going to use it, either earlier in the day or in context to a workout recovery, that's going to be the most forgivable metabolically times to have it. Because the later in the day you have it, the closer you get to having to go to sleep and, having to go to sleep and, have this glucose seeping into your bloodstream while you're trying to sleep. And then now all this stuff is going on. All this metabolism is going on when your body is supposed to be regenerating itself, and your body doesn't regenerate and you get less out of your sleep. And a lot of people will say, oh, that's hooey. I eat a big dinner all the time. But you know what? You've gotten so used to it. You don't know what it's like to get a good night's sleep anymore. Right. I challenge everybody who insists on eating a big dinner. I challenge you for a week to eat your biggest meal at breakfast and lunch and to just forego dinner. And this excludes people on insulin. Okay. I don't want you to get hypoglycemic. And this
is also not medical advice.
But for folks that don't have a lot of medical problems that want to do this experiment, if you insist on eating a big dinner, I challenge you to go to breakfast and lunch, and see how your sleep quality changes. Just try it out.
And the reason I'm probing in this direction, so the insulin resistance possibly correlated to excess abundance of food, particularly non-nutritional food, non-nutritional calories. One remedy is fasting, which maybe we'll get into in another episode. But the dopamine surges, which we also didn't really cover yet in any episode.
Yeah.
Because all these things are connected, right? Like testosterone, dopamine, insulin resistance. We're in an epidemic of crashing levels of dopamine due to excess of stimulants such as social media,
Yeah.
I mean, when you say go on a food fast, people are also saying go on a social media fast.
You're just going a phone fast.
Go on an internet fast.
Yeah.
Like just remove stimulus to increase your baseline dopamine levels.
Yeah.
And so I guess the Western lifestyle is abundance, but it's also like cheap abundance. It's not like back in the day, I keep bringing up caveman times, but you wouldn't have abundance, but when it came, it was not cheap. It was like well earned, well deserved. You had to work for it.
Yeah.
Nowadays, I get dopamine like just looking at my phone. And if I don't have my phone for an hour, I'm going crazy. Like I gotta check it. I gotta check it. And same thing with food. I think like there's themes there, and there's got to be a way for all these things to be connected somehow.
It is all connected. It's all connected, and the chemicals we talked about in the hormone video, the second video that we made, that I think feeds into the attack on people's hormones and brains, whether it was intended or not, from various industries, that is contributing to I think the cortisol problem, because you have people that feel like they have no direction in life, that they're just like, oh, I don't know what I'm going to do. I'm not motivated to do anything. And I mean, they're coming out of high school and they don't know what they want to do, or they don't want to do anything. And like, that's crazy. You have your whole life ahead of you. You should be trying to get ahead. You should be trying to do something for yourself. You should have goals. And so that motivation, that lack of oomph, that lack of motivation, I think it stems from this dopamine crisis that we have, where there's these peaks and troughs, and we don't have that like healthy baseline that's there.
The baselines are ever decreasing.
Yeah, like try to talk to people about taking a cold shower now, just for wellness, and they can't. I mean, I try to do it every once in a while, and I mean. If you haven't done it in a while, it's
I love cold showers. Yeah, but the winter time is best here.
Yeah, but they're so good. You feel so good afterward.
Yeah, you do. Yeah. But also what it does for your circulation.
Mm-hmm. Yeah, like it's the same reason why if you're out in the forest, and one of my best friends, he taught me this when we were out doing some bushcraft camping with like almost nothing on a winter solstice night in the mountains. He said, stick your hands in the freezing cold river to warm them up. You stick your hands in there, and I'm pretty sure it's heat shock protein, HSP, and probably a bunch of other signaling proteins. Your hands are freezing and you're like, what am I doing? I'm crazy. And then you dry off your hands. And then after a while, your hands just turn into fireballs, and then your hands get really warm. And then you can do more work in the forest with whatever you're doing, working on your campsite. So that's just a cool little thing. But again, people with vascular disease and neuropathy probably shouldn't do that, right? But talking to the outdoorsy types.
So we have all these manifestations of I guess comorbidity. I mean, isn't that what they're called? Like a lot of these things that go hand in hand, comorbidities.
Comorbid conditions, comorbidities.
Because we have an obesity study starting, and if you're over 65, they want two comorbidity or one comorbidity only, and obesity, one or more to get in. But if you're under 65, they want two plus the obesity. So they include hypercholesterolemia, diabetes, hypertension, a couple other things as comorbidities in addition to the obesity. So, but the interesting thing is we're pre-screening for these patients. That's not challenging at all. Like those go hand in hand for the most part.
Yeah.
Do you know anyone who's obese that is otherwise healthy? Have you ever met someone?
Yeah, I have. I have. There? Yeah, a few. There's a few. Just like
But is that because they're young and hasn't caught up to them yet, or just that's how they are?
Probably a part of it. But I know there is a patient from an Eastern European country who was quite large. And that person did not have any diabetes. I remember, and they were closer to a middle age. I think they were in their 40s. So that was
someone like that, like the outliers. I think there's some value in studying the N of 1 What do you think it was there? Like,
I don't know. It could have just been a group of people in a part of the world where they, again, epigenetically had to adapt to their environment. You know, kind of like Native Americans had to adapt to prolonged fasting.
Yeah.
In severe conditions. You know, maybe there's a similar thing in people in snowy conditions.
I see. Yeah.
You know, like the Inuit have a relationship with all of the animal fat that they need to consume. Mm-hmm. You know, so I'm sure there was something there.
So maybe we find a connection somehow in the Dr. Joe show of kind of how all these things are connected. Dopamine, hormones, insulin resistance, cholesterol, hypercholesterolemia, obesity. There's got to be a few common factors, or at least from a theoretical standpoint. Mm-hmm. And go from there, I guess. Fasting is a good podcast in and of itself, too. Fasting and keto.
We could do one about fasting. A lot of people have already mostly cracked the code on fasting. It's just, I think the biggest thing is motivating people to actually do it. And because once they start doing it and not seeing it as a diet and more as a mindset and a habit and a lifestyle. That they adopt, then it just becomes a part of them. I said, nope, I don't eat dinner anymore. Not me.
Yeah.
I'll just drink water. And that might be weird initially. And then you just get used to it. And then, and then you might rub off on some people, and then everybody's going to start dropping weight. Like there's no,
then you're establishing a new normal for yourself.
Yeah. Dropping weight like there's no Ozempic.
But not medical advice, guys. It's just a YouTuber and his thoughts.
No, it's just a casual discussion.
Anything else we should explore? Another podcast that stems from this conversation?
Anything else? I mean, we've already, I think we've touched on, I don't know, at least 5 or 6 different podcasts that we could do in the future.
Yeah, at least. And then we haven't even gotten into the scientism.
Yeah.
I think we have to build up to that one. Like we're
building up to the scientism.
Yeah. Because that's your theory.
Yeah. Well, I think it's beyond theory now. I'm pretty sure that we have more than enough evidence of scientism.
We just have to build up on our channel. Like we get into it slowly.
We just choose which industries are going to be revealed.
Yeah. And a lot of them are to blame, but thank you guys. Drop your comments below. Like, subscribe, comment, share. When you're getting a Twitter, you getting one anytime soon?
I will.
Not to put you on the spot, but
yeah, I need to think of the name of the account and everything. It takes me a long time to decide to do something like that.
Let us know in the comments if Dr. Joe should have a Twitter, and if
should I get a Twitter account,
Twitter handle.
Well, see, now we have to wait for this video to be posted, and then I'll decide.
So you got another month at least.
So I got another month to decide.
Yeah. All right, and stay tuned for the shorts, guys. Like, subscribe, comment, share. Talk to you guys later. Bye-bye.